the astonishing secrets of the moons in our solar system. Far beyond the familiar image of barren, silent rocks drifting through space, the moons of our solar system reveal a universe far more dynamic, mysterious, and alive than we once imagined. These natural satellites, some small and irregular, others massive enough to rival planets, hold clues to the origins of worlds, the mechanics of gravity, and perhaps even the existence of life beyond Earth. Orbiting giant planets and dwarf worlds alike, moons are shaped by powerful forces, tidal heating, gravitational resonance, and ancient cosmic collisions. Over time, these forces have transformed them into complex worlds, each with its own story written across ice, rock, and atmosphere. Take Europa, one of Jupiter's most intriguing moons. Its surface appears smooth and bright, covered in a thick crust of ice crisscrossed by dark streaks. But beneath that frozen shell lies something extraordinary, an enormous global ocean of liquid water. Scientists believe this ocean may contain more water than all of Earth's oceans combined. Heated not by the sun, but by the immense gravitational pull of Jupiter, Europa's interior remains warm enough to keep this ocean from freezing solid. On Earth, wherever there is liquid water, there is life. This simple fact makes Europa one of the most promising places in our search for extraterrestrial organisms. Not far from Europa, another Jovian moon tells a completely different story. Io is a world of fire. It is the most volcanically active body in the solar system, with hundreds of erupting volcanoes scattered across its surface. Massive plumes of sulfur and ash shoot hundreds of kilometers into space, painting the moon in shades of yellow, red, and black. The intense activity on Io is caused by tidal forces. Jupiter's gravity stretches and compresses the moon, generating immense internal heat. Io reminds us that moons are not just passive objects. They are shaped and reshaped continuously by powerful cosmic interactions. Moving outward to Saturn, we encounter Enceladus, a small icy moon that has shocked scientists with its hidden activity. At first glance, Enceladus appears bright and frozen, reflecting sunlight like a mirror. But near its Duction polar region, enormous geysers erupt, blasting jets of water vapor, ice particles, and organic compounds into space. These plumes originate from a subsurface ocean hidden beneath layers of ice. The material ejected from Enceladus even contributes to Saturn's rings, creating a direct connection between the Moon and its parent planet. The discovery of organic molecules in these plumes suggests that the building blocks of life may already exist there. Then there is Titan, Saturn's largest moon, a world that feels strangely familiar and completely alien at the same time. Titan possesses a thick atmosphere composed mainly of nitrogen, much like Earth. However, instead of water, its surface hosts lakes and rivers of liquid methane and ethane. Rain falls from orange clouds, carving channels and valleys into the landscape. Titan's chemistry is incredibly complex, with organic molecules forming in its atmosphere and settling onto its surface. Some scientists believe that Titan may resemble what early Earth looked like before life began, offering a window into our own planet's distant past. Beyond Saturn, in the cold outer reaches of the solar system, lies Triton, Neptune's largest moon. Triton stands out because it moves in a retrograde orbit, meaning it travels in the opposite direction of Neptune's rotation. This unusual motion suggests that Triton was not formed alongside Neptune, but was captured by its gravity long ago, possibly originating from the Kuiper Belt. Triton is also geologically active, with geysers that spew nitrogen gas across its frozen surface. Despite the extreme cold, this distant moon continues to surprise scientists with signs of internal energy. Among all moons, Ganymede holds a special place. It is the largest moon in the solar system, so large that it exceeds the size of the planet Mercury. Yet Ganymede is more than just big. It is the only moon known to have its own magnetic field, a feature usually associated with planets. Beneath its icy crust, scientists suspect that Ganymede also harbors a deep ocean of salty water. This combination of size, structure, and magnetic properties makes it a unique object of study, blurring the line between moons and planets. Another fascinating moon of Saturn, Iapetus, presents one of the most striking visual contrasts in the solar system. One hemisphere is incredibly dark, absorbing most of the sunlight that hits it, while the other is bright and reflective. This dramatic difference gives Iapetus a two-toned appearance, as if it were composed of two entirely different worlds fused together. Scientists believe this contrast is caused by a combination of external material coating one side and thermal processes that amplify the difference over time. But perhaps the most profound realization about moons is that many of them are not isolated systems. They interact continuously with their parent planets and with each other. Gravitational forces create tidal heating, orbital resonances, and even internal oceans. These interactions can generate energy in places where sunlight is weak or non-existent, creating environments that may be suitable for life. The concept of habitability is no longer limited to planets orbiting within a narrow Goldilocks zone. Moons, once considered unlikely candidates, are now at the forefront of astrobiological research. Subsurface oceans, chemical energy sources, and organic compounds all combine to create conditions that could potentially support life. Worlds like Europa and Enceladus challenge our assumptions and expand our understanding of where life might exist. In addition to their scientific importance, moons also hold clues about the history of the solar system. Their compositions, structures, and orbits preserve records of ancient collisions, migrations, and gravitational interactions. By studying them, scientists can reconstruct the events that shaped the planets and the system as a whole. As technology advances, new missions are being planned to explore these distant worlds in greater detail. Spacecraft equipped with advanced instruments will probe beneath icy crusts, analyze plumes, and map surfaces with unprecedented precision. These missions may one day answer one of humanity's oldest questions: are we alone in the universe? The moons of our solar system remind us that even in the coldest, darkest corners of space, there is complexity, motion, and possibility. They are not merely companions to planets, they are dynamic worlds with their own identities, histories, and secrets waiting to be uncovered. And as we continue to explore them, one thing becomes increasingly clear. The story of the solar system is far richer and more extraordinary than we ever imagined. And its most fascinating chapters may be written not on planets, but on the moons that orbit them.